Hello guys, in this video I'm going to explain about two named reaction from the AMINES chapter of organic chemistry. First of all is Curtius Rearrangement. The second one will be Lossen Rearrangement. So first of all, this is Curtius Rearrangement. Curtius Rearrangement is the conversion of an acyl azide okay, into an isocyanate in thermal condition, right? So this is conversion of what? Acyl azide into this is cyanate, okay, this is isocyanate. So this is in thermal condition, right? So acyl azide is RC double bond O, then N3. This is acyl azide, and if it is heated, then we will get what? Isocyanate. Isocyanate, okay. N double bond C double bond O. This is isocyanate. Okay, let me give the mechanism of this reaction. The mechanism is, let me change the color. Okay, now this is acyl azide, which can be represented as like this, N double bond N double bond N. Okay, this nitrogen will carry a positive charge and this nitrogen will carry a negative charge, and this will have two lone pair of electrons. This nitrogen also has a lone pair of electrons. Okay, now if it is heated, then what will happen? This two electron will form a pi bond here. This pi bond will be broken to go to this nitrogen, so we will get RC double bond O, and will carry now a negative charge because it accepts two electrons, and this nitrogen will have two lone pairs of electron now. Okay, let me show like this. Okay, now this will be a single bond nitrogen. Now there will be a triple bond between these two nitrogen atoms like this, and this nitrogen will have a positive charge, not this one, sorry. Okay, this nitrogen will have a lone pair of electron, but this nitrogen will carry a positive charge now. I carried before also, but now negative charge shifts from this nitrogen atom to this nitrogen atom. Okay, now what happens is, when this two electron forms a pi bond here, this pi bond will be broken, and we will get R C single bond O, and this oxygen will carry a negative charge. There will be a double bond here, nitrogen, and then nitrogen plus triple bond nitrogen with a lone pair of electron like this. Okay, now when this two electrons forms a pi bond between carbon and oxygen, this bond will be broken and the alkyl group will shift from here to this nitrogen atom, right? Then this bond will be broken. Let me show with a different color. This bond will be broken and the two electrons will go to this nitrogen atom to form nitrogen gas. So we will get this R will be attached to this nitrogen atom, R nitrogen. To this nitrogen atom, carbon is attached with a double bond, and to this carbon atom one oxygen is attached. This forms our isocyanate, right? And the byproduct will be plus nitrogen gas. This is our nitrogen gas, N2, right? This is our isocyanate. Okay. This is the mechanism of Curtius rearrangement. Now let me do one more name reaction in this chapter. For that I need to rough this page. Okay, the second one is Lossen rearrangement. Okay, this is Lossen rearrangement, and in this rearrangement hydroxamide, it is the conversion of, let me write some text here, conversion of a hydroxamate ester, or we can say hydroxamic acid into an isocyanate. Again, this is the Lossen rearrangement. This isocyanate can be, which on hydrolysis produces an amine, right? This is Lossen rearrangement. Okay, let me write the reaction. This is hydroxamate ester or hydroxamic acid. This can be written like this. This is RC double bond O, and this is our amide. To this nitrogen atom O, C double bond O R can be attached. This is our hydroxamate ester. So to this part there can be one, and there can be hydrogen also. In that case the reactant will be hydroxamic acid, right? And if it is, this is our hydroxamate ester, okay, this will be converted into what? R N double bond C double bond O. This is our isocyanate, right? This is our isocyanate, and this reaction also occurs in thermal condition. So we need to heat this reactant to convert or to do this rearrangement, right? Okay, let me do the mechanism. This is the mechanism. Let me change the color of the pen. Okay, now when this reactant is heated, what happens is this reaction occurs in presence of a base also, right? So the reaction will be initiated by reacting with the base. So let me write here RC double bond O. This is N, to this N, one hydrogen is attached, and this hydrogen is acidic in nature. This is our hydroxamate ester, and if it is reacted with this base, then this base will abstract this hydrogen, and these 2 electrons will go to nitrogen atom in the form of lone pair of electrons, right? So this will be let me write here. This will be RC double bond O, and to this nitrogen atom negative charge will be there with 2 lone pairs of electron, and this will be like this, right? So when these 2 electrons form a pi bond between this carbon and nitrogen, this bond will be broken like this. This rearrangement is also similar to Curtius rearrangement. So what we get is this one, RC single bond O minus, and there will be a double bond between nitrogen and carbon, and this is O C double bond O R. Now when this, change the color again, when these 2 electrons form a pi bond here, this bond is again broken, and the alkyl group shifts from carbon to this nitrogen atom, and then means this bond is broken, and then this bond is again broken, and the 2 electrons will go to oxygen atom, right? So we are going to get what, let me write here, this R is attached to this nitrogen, R attached to this nitrogen, and to this nitrogen atom there is a double bond and with carbon atom, and to this carbon atom another oxygen is attached with the double bond. This is our isocyanate, right? And in the byproduct there will be RCOO minus. Okay, this will be byproduct. I am not writing that byproduct. Now this is our isocyanate, and if this is reacted with water, means hydrolysis is done, then oxygen has a lone pair of electron, and this gives its electron to whom? To this carbon, and this pi bond is broken like this. So we will get Rn minus, and that N minus will abstract a hydrogen from this O, so this will form NH. Okay, and this, there will be a single bond between nitrogen and carbon, and to this carbon atom OH will be attached, right? OH will be attached, and to this carbon again there is another oxygen atom with a double bond. This is the means intermediate. Now if this intermediate is again reacted with that base, let me write B minus, and this B minus will abstract this hydrogen like this, and there will be a formation of a pi bond between carbon and the oxygen, and this bond will be broken, and the 2 electrons will go to nitrogen atom. This bond will be broken. Okay, so we will get this Rn minus, and to this N minus one hydrogen atom, this hydrogen atom you can say will be attached. So we will get RnH2, and this removal of carbon dioxide takes place in the form of gas, and we get this our primary amine, right? This is our Lossen rearrangement, right? And another named reaction is also there, but let me do that reaction in the next video. For this video, let me complete here. I hope it is clear to you all. Please share this video to your friends if you like, and if you are new to the channel, please subscribe and also press the notification button. Thank you.